think so everyone they may be studied about the isomerism. Okay. So here, what is mean by the isomerism and who introduced the term isomerism means here, the term isomerism is introduced by Berzelius. Okay. So who introduced the term isomerism? Isomerism, the term introduced by Berzelius. Okay. And actually isomerism is a Greek word. Isomerism is Greek word. According to the Greek word, iso means same or equal, same or equal, and meros. So meros means parts. Meros means parts. So based on this one, how we can define the isomerism means here the compounds which are having which are having same molecular formula, same molecular formula. Compounds are having same molecular formula, but but differ in the any one of the functional group. Okay, sorry, any sorry, any one of physical property, any one of physical property, physical or chemical properties, physical or chemical properties, chemical properties. Okay, the compounds are called isomers. The compounds are called isomers. The compounds are called isomers. And the phenomenon is called as a isomerism. And phenomenon is called isomerism. Okay, the phenomenon is called as a isomerism. Sir, what is with the isomerism? Means compounds are having same molecular formula but differ in that any one of the physical or chemical property of the compound is called as a isomers, and the phenomenon is called as a isomerism. Sir, how they're getting as a different in physical properties and chemical properties? I think so. Already know what are the examples of the physical properties, sir? Is any examples of the physical properties? What are the examples of the physical properties, ma'am? What is the physical properties? Aditi, Anjan, Samhita. What is mean by the physical properties?
Color and smell.
Okay. So what is mean by the physical properties, ma'am? The properties which we can see and measure is called as a physical properties. Sir, what are the examples of the physical properties? Means boiling point temperature, melting point temperature, density, undertow. All these are we can consider as the physical properties. Okay. So if they're having same molecular formula, if any one of the physical or chemical properties are changes, means that we can call as a isomerism. Okay, how they are going to be changed is based on the arrangement of atoms. Okay, so based on the structural representation, the properties also is going to be changed. Okay, again, isomerism is classified into two types. Again, isomerism is classified into two types. What are the two types of the isomerism we are having? Means one is called as a structural isomerism. Structural isomerism. Another one is called as a stereoisomerism. Another one is called as a stereoisomerism. Okay, so isomerism again, isomerism is classified into how many types? Again, isomerism is classified into two types. What are the two types of the isomerism? It is the okay, so one is structural isomerism and another one is stereoisomerism. Sir, in this one, first of all, what is meant by the structural isomerism? What is mean by structural isomerism? Chanakya, Sri Veda, Sai Akshit. Madhusudan is absent today. Sai Akshit. Right. So what is mean by the structural isomerism? What is mean by the structural isomerism? So structural isomerism means two or more number of compounds are having same molecular formula but differ in their arrangement of the atoms. Okay, or differ in the structural arrangement of the atoms is called as a structural isomerism. Okay, so all of you got the clarity, sir. What is meant by the structural isomerism means compounds are having same molecular formula but differ in their structural arrangements is called as a structural isomerism. Okay, sir. Again, under the structural isomerism is classified into different types. What are the different types of the structural isomerism? It is there means here. One is chain isomerism. One is chain isomerism. Second one is position isomerism, position isomerism, and third one is functional isomerism, functional isomerism. Fourth one, metamerism, metamerism. Okay, and fifth one, tautomerism, tautomerism, and sixth one, ring chain isomerism. Sixth one is ring chain isomerism. So all these are the different types of the structural isomerisms. Okay, so then, so next we will study about the deeply, sir. What is the chain isomerism network? Again, similarly, stereo isomerism is classified into two types. Again, stereo isomerism is classified into two types. Okay, so what is meant by the stereo isomerism is the spatial arrangement of the atoms or group of atoms around the carbon. Okay, around the carbon is called as a stereo isomerism. So what is meant by the stereo isomerism means? It is the spatial arrangement of the atoms or group of atoms around the carbon in a molecule is called as a stereoisomerism. Okay, and stereoisomerism is classified into two types. What are the two types of the stereoisomerism we are having means? One is conformational isomerism. Conformational isomerism. Okay. Second one is configurational isomerism. Configurational isomerism. Okay, so one is the conformational isomerism, another one is configurational isomerism. Okay, so in this one, first one we can check it out. First one we can see structural isomerism. So under the structural isomerism, we have a different types of the isomerism now. What are the different types of the isomerism we are having? First one is chain isomerism. First we'll discuss about here structural isomerism. Structural isomerism. Okay.
Sir, could you once scroll up?
Scroll a little bit up, ma. Okay. So if you want a tabular column, means you can take.
None, sir.
Done, ma. Right. Is any speed is there, class? I think so. I'm going a little bit speed. It's okay for you.
Sir,
Okay. I think so. I'm going a little bit speed. It's okay for you.
sir,
Hi, Triveda. How are you?
fine, sir.
Uh,
Sir, in structural isomerism, we have only 5 types, sir.
So what are the 5 types you read, ma? Actually, 6 types is there. Ring chain what are the types you studied, ma? Just to tell me that.
Chain isomerism, position isomerism, functional isomerism,
Hmm.
metamerism,
Metamerism, tautomerism, okay, tautomerism, and ring chain isomerism also it is there. So because of if you go for the NEET level and means they'll teach up to only metamerism, sir. Okay, but I think so somebody they may be prepared for a GE and advanced level also it is there. If you go for the advanced level means so based on the tautomerism they're asking the questions. And if you want to check it out means you can check it out the previous year papers also.
yes, sir, but they taught us only 5 types, not the 6 types. That's why I'm asking.
Okay. Actually, ring chain isomerism also it is there. Okay. So where we will get as a ring chain isomerism means so whenever we want to calculate the total number of structural isomerism means that time we have to consider ring chain isomerism also. Okay. Now you got the clarity, Sriveda?
Yes, sir.
Okay. So right now. So then we'll go for the next concept here. Okay. So we are going to study about here structural isomerism. Okay, structural isomerism. So under the structural isomerism, we are going to study about here chain isomerism, position isomerism, functional isomerism. Okay. First one is chain isomerism. So what is meant by the chain isomerism? What is mean by chain isomerism?
When they have different numbers of carbon in a chain.
Very good. Different number of carbon atoms in a chain. Okay. So compounds are having same molecular formula but differ in their chain length. Okay, so differ in their chain length is the two compounds are we can call as a chain isomers and the phenomenon is called as a chain isomerism. Okay, so chain isomerism also we can call as a nuclear isomerism also. Okay, this also we can call as a nuclear isomerism and this is also we can call as a skeletal isomerism. This also we can call as a skeletal isomerism. Okay, so to exhibit this chain isomerism, compound it has to be minimum 4 carbon atoms. Okay, the compound has to be contains minimum 4 carbon atoms. Then only it exhibit as a chain isomerism. If it is having 2 carbon atoms or if it is having 3 carbon atoms means it does not exhibit as a chain isomerism. To exhibit the chain isomerism, minimum how many carbon atoms it has to be there?
4, sir.
So minimum 4 carbon atoms it has to be there, sir. Okay, sir, what is the best example we can take means here, sir, butane. So what is the molecular formula of the butane means C4H10. Okay, so C4H10 is called as a butane. Okay, from butane onwards only it exhibits as a chain isomerism. Okay, so from propane and ethane are they does not exhibit as a chain isomers. Okay, so already we wrote some common names N-butane, isobutane. So do you have anyone? So idea about that one N-butane. What is meant by the N-butane? N-butane. I think so. Last time we discussed N-butane. What is meant by the N-butane? Bute means how many carbon atoms?
4.
4. Okay. If all 4 carbon atoms are present in a straight line, that means CH3 bond CH2 bond CH2 bond CH3. If all carbon atoms are present in a straight line, mean that we can call as a N-butane. Okay, and we can write one more structure also. What is the another structure means here? Isobutane. Isobutane. So what is meant by the isobutane means if the last but one carbon atom is attached with one methyl group. So this is the last carbon atom. So but one means this carbon atom only na. If this carbon atom is attached with the one methyl group is called as a isobutane. Okay. Now you can check it out, sir. So both are having same molecular formula only. N-butane also having same molecular formula. Isobutane also it is having same molecular formula. But what's the difference it is there in these two? What is the difference it is there in these two structures?
Length of carbon chain.
Very good, ma. So length of the carbon chain. In the first one, in a carbon chain is having the 4 carbon atoms. In the second one, in the carbon chain, so carbon chain length is having 3 carbon atoms. But both are having same molecular formula, but differ in the number of carbon atoms in a chain length is called as here chain isomerism. Okay, so in this one, which property, which physical property we can differentiate means here boiling point temperature. If you see N-butane and isobutane, in N-butane and isobutane, which one is having the greater the boiling point temperature means N-butane is having the greater the boiling point temperature than that of isobutane. First, I'll write the numbering one. For this one, I can give the first number and second, I'll give this number here. If you see boiling point temperature, sir, which one is having the greater the boiling point temperature means first structure is having the greater the boiling point temperature than that of the second structure. Okay, so is any other reason? What is the reason why the first structure is having the greater the boiling point temperature?
Because isobutane is a branch structure and
Very good.
Sir.
straight structures are more stable, sir.
Aditi is giving some other reason.
So, like more number of carbons in a chain or less branches is directly proportional to boiling point.
Very good. Okay, so less branches here, more number of carbon atoms are increases and less branches mean that is also correct only. Directly proportional to so their boiling point temperature. So simply we can say surface area also we can consider. Okay, if the number of branched chains are decreases means greater the surface area. Okay, surface area is increases, their boiling point temperature also is going to be increases. Okay, so due to that reason only here, sir, first structure is having the greater the boiling point temperature than that of the second one. Okay, now I'll give one more structure, one more example. Sir, what is the general formula of the pentane? Molecular formula of the pentane? We can write as a C5H12.
Yes, sir.
C5H12. Okay, sir, if the C5H12 means how many chain isomers it is exists, sir? Pentane is exists how many chain isomers? Any one of you? Pentane is going to be exist how many chain isomers? Sir, pentane is exist as a 3 chain isomers. So how many chain isomers it is exists, sir? 3 chain isomers it exists. Sir, what are the names of the 3 chain isomers means that we can call as N-pentane, N-pentane, isopentane, and neopentane. N-pentane, isopentane, and neopentane. Okay. Now, in these 3 structures, so which one is having the greater the boiling point temperature? Which one is having the greater the boiling point temperature?
Neopentane.
Neopentane or N-pentane?
N-pentane.
Jan, you are giving wrong answer today. What happened to you? If you want a structure means you can write like the structures.
We asked about high boiling point.
Which one is having the greater the boiling point temperature?
Okay, I thought
No, sir. Clearly, I asked which one is having the greater the boiling point temperature. Okay, and one more question also I can ask here. So in these 3, so boiling point temperature is increases or decreases? From N-pentane to neopentane, boiling point temperature is increases or decreases? That is one more question.
Decreases.
Very good, Veda. Okay, so from N-pentane to neopentane, boiling point temperature is going to be decreases. Okay, so Sriveda, you told that boiling point temperature is going to be decreases. At the same time, can you tell me the reason why it is going to be decreases?
Because of the branch chain.
Very good, ma. Okay, so number of branched chains are increases. The boiling point temperature also is going to be decreases. So due to that reason only N-pentane is having the greater the boiling point temperature. So all of you got the clarity? So still anyone you having doubt? Okay, so then can I go for the next isomerism?
Yes, sir.
Okay, sir, all these N-pentane, isopentane, neopentenes are we can call as a chain isomers. Okay, so because of they having the same molecular formula but differ in their chain line. Whenever they having the differ in their chain line, means that we can call as a chain isomer. Okay, next. So next we'll go for sir positional isomerism. Okay, so next one we'll go for position isomerism. Okay. So position isomerism. Position isomerism. So what is meant by the position isomerism means here the compounds are having same molecular formula but differ in that. Okay, the compounds are having same molecular formula, but differ in that, position of the substituent and position of the functional group. Differ in the position of substituent, and position of functional group. Position of functional group also. Okay, so the two isomers are we can call as a position isomers, and the phenomenon is called as a positional isomerism. Sir, what are the examples means? For example, I'll take here. I think so while writing the IUPAC names of the aromatic compounds, we wrote some structures. Okay, what are the examples means? Dihalides we wrote. Okay, so in this one, Cl, bond Cl, and I'll write one more example. Here also Cl, and here also Cl, and so these two also Cl and Cl. So first you observe all these three structures, ma. What's the difference it is there in the three structures?
Position of functional groups.
Position of
Functional groups.
chlorine is substituent. Chlorine is the
Yes,
substituent. Okay, so if you see names, while writing the IUPAC names, what is IUPAC name we wrote for the first one? 1,2 dichlorobenzene we wrote. Is it right?
Yes.
So what is the name of the first one we wrote means 1,2 dichlorobenzene. Then what about the IUPAC name of the second one?
1,3 dichlorobenzene.
Very good one. 1,3 dichlorobenzene. Okay. Then what about the fourth one? Fourth one.
1,4 dichlorobenzene.
1,4 dichlorobenzene. Okay. Sir, what you observed in this one means all are having same molecular formula only, but differ in their position of the substituent. Okay, so two chlorine atoms are there. If you observe the first structure means here, so chlorine atoms are present at 1 and 2 position. While coming to the second structure, so chlorine atoms are present at 1 and 3 position. Okay, and while coming to the third structure, so chlorine atoms are present at 1 and 4th position. Okay, so due to that reason only, all these are we can consider it as a positional isomers because of the having the same molecular formula but differ in their positional isomers. And I'll give one more example to you, sir. Okay, what is another example means? So if I wrote, sir, like this structure, simply I wrote like this. I don't know the names. Sir, is these two structures, sir, can we consider it as a positional isomers? Is these two
Yes, sir.
structures, sir, we can consider it as a positional isomers?
Yes, sir.
Yes.
So how are you telling that these two are we can consider as a positional isomers? What's the difference it is there in this one?
They differ in their position of double bonds.
Very good answer. Okay, so both are having same molecular formula only. But what's the difference it is that means here position of the double bond. If you see in the first structure we can write as a 1-butene. What is the impact name we can write means here? So 1-butene we can write. And what is this second one means we can write as a 2-butene. Okay, so 2-butene we can write. So 2-butene means double bond is present at second carbon atom. Okay, and I'll write one more structure. Is these two structures are we can consider as the positional isomers?
Yes, sir.
How you are telling that these two are we can consider as a positional isomers, ma? Veda?
The position of OH.
Very good, ma. So position of the OH group is different in the both the structures. Both the structures are having same molecular formula. Okay, so first one is called as a 1-butanol. This we can call as a 1-butanol. So this we can call as a 2-butanol. Okay, that we can call as a 2-butanol. So what's the difference means position of the OH group? If the position of the OH group is different, means that we can call as a positional isomers. So now you got the clarity, all of you here. Still anyone having doubt? Everyone you having clarity now? Say yes or no.
Yes,
Sir, once
sir.
can you explain about ISO term? Like how we can say that it is ISO?
Iso.
Huh. Like
Anjan,
we say
come again.
about second butanol, is that isobutanol? We can call it as.
No, sir. So we can't call as a isobutanol, sir.
So
Okay.
how compounds are like called as isobutanol or something related to
Very,
ISO?
very good, very good, very good. I'll ask. I'll explain, sir. Okay. So now I'll explain here. So you're asking now. So actually, sir, what is meant by the N means N is signifies if the all carbon atoms are present in a straight line mean that we can represent with the N. Okay, and what is mean by the iso means last but one carbon atom. Okay, let us see. This is the carbon chain. Last but one carbon atom is last carbon is this one only. Okay, but one carbon atom is this we are going to be considered. Okay, so last but one carbon atom. If the last but one carbon atom is it is attaches with only one methyl group. If the last but one carbon atom is attaches with only one methyl group is called as a iso. Okay, and here neo. What is meant by the neo means? So neo is nothing but last but one carbon atom is attaches with the two methyl groups. So last but one carbon atom is this one only, na? So this one is attaches with the two methyl group mean that we can call as a neo. Okay, now,
Sir,
so
in
Anjan, you
place
are asking. Yes,
in place
Anjan.
of that in place of that methyl group, is there any like OH or
No.
alkyl ketone?
We can't write. We can't write. So if it is methyl group only, it is that only we can call as a iso and neo. Other than methyl and other alkyl groups are there, means that we cannot write.
So there's an example CH3 single bond CH single bond CH3, and to that CH3 there is attached OH, so it is isopropyl alcohol.
Anjan, 1 second. So Anjan, you are telling that something.
There is an example CH3 single bond CH
Hmm.
attached to OH, and then CH3 single bond CH3
Yes, Anjan.
isopropyl alcohol.
Yes, Anjan. So you are telling that like this. Okay. So how they are writing the structure means CH3 bond, CH bond, CH3 bond OH. Right now,
Yes.
this is what isopropyl alcohol means. Because of let us see. So this is the strike root word. It is a root word, right?
Actually, in
So
place of that CH3 there is OH, and in place of that OH there is CH3. So this is
yeah.
called as
So
isopropyl alcohol.
somebody they'll write like this also. CH3 bond, CH bond, OH bond, CH3 also they can write.
So that's what I'm asking. Like,
Yeah. So, but if you see in his total, how many carbon atoms are there? 3 are there. right? So these both are same or different?
Same. Which three? Like positions.
Same position is same. Hydroxy position is not going to be changed, na? That's why. So this also we can call as isopropyl alcohol. Then this also we can call as a secondary alcohol also. Secondary propyl alcohol also we can call. So why we are calling as a secondary propyl alcohol, sir? Any one of
Because it is
you?
attached to because it is attached to two carbons. Like that's
Secondary
CH.
carbon, sir. If the OH group is attached to the secondary carbon, that is also we can call as a secondary alcohol. Now you got the clarity?
Okay, sir.
Okay. Then sir. So next. So next we'll go for functional isomerism. The next we'll go for functional isomerism. Sir, what is meant by the functional isomerism? First of all, what is meant the functional group?
Which contains different functional groups.
I'm asking definition of the functional group, Maveda.
Ah,
What is meant by the functional group means? So
They
a
have
group
same
of
molecular formula but different functional groups.
I'm asking the definition of the functional group. I'm not asking the functional isomerism. So functional group is nothing but a group of atoms which are responsible for the chemical property of the compound is called as a functional group. Okay, according to that only we wrote as some different types of the functional groups. Okay, so we have a different types. So what are the different types of the functional groups we are having? Means carboxylic acid functional group, ester functional group, anhydride functional group, amide functional group, acid chloride functional group, aldehydes, ketones. So actually, if you write aldehyde functional group, means how you will write, sir? Which we can call as aldehyde functional group. What is the aldehyde functional group? Come on.
All
Functional group, ma. How we can identify? So, for example, I wrote something. How we can identify the given structure is aldehyde or not? Sir, I'll write one structure
suffix.
here. Okay. So, for example, just I'll write here. So, one example only I'm writing. Sir, here CH3, CH2, COOH I wrote. Okay. Now, one more structure I'm writing. CH3, COO, CH3 I wrote. So, these two structures I wrote, sir. Sir, in this one, which one is the carboxylic acid functional group and which one is ester functional group? Now you tell me, sir. So we already studied the functional groups. We had seen the IUPAC nomenclature of the functional groups. Okay. Now, which one is acid carboxylic acid functional group and which one is the ester functional group? Sir, while coming tomorrow, please all of you just go through the IUPAC nomenclature rules and regulations and what are the functional groups we discussed. Just go through that one and you can come. So because of functional group isomerism means you have to know the difference.